Welcome back to Math 107 College Algebra. In this video, we're going to take a look at the idea of solving a system of equations using an inverse matrix. So we're going to let our system of equations be the form. Let me get the right color pen here. AX equals B, where x is going to be a column vector consisting of our variables. So in the case of the equation I'm going to give you, that's the column vector xy. B is going to be the right-hand side of our equations written in standard form, and A is going to be the matrix that we had before. So now if I multiply on the left-hand side of each of these, let me give myself a little bit more space. I'm going to multiply on the left by A inverse. Well, now I'm going to use the fact that matrices are associative. So I have A inverse times A multiplied by X. Well, now, A inverse times A, by definition, is the identity. And then, the identity, by definition, multiply that by anything, you just get what you're multiplying it by. So now, how does this work in a practical example? So I'm going to give you the system 4x minus 3y is equal to 4. And 3x minus 2y is equal to 5. And we're going to solve this using the inverse matrix. So first, our equation is, getting ahead of myself here, 4, negative 3, 3, negative 2, that matrix, multiplied by the matrix column vector xy is equal to 4, 5. Now, in the last video, we found the inverse of this matrix. So if I multiply on the left of both sides by that, we know that that's going to go to the identity, which is just going to end up giving us xy. So that's going to equal our inverse matrix, negative 2, 3, negative 3, 4, multiplied by the column vector 4, 5. So I bring that up, and I end up getting that the vector xy is equal to, so in the first term, I get negative 2 times 4 plus 5 times 3. In the bottom one, I get negative 3 times 4 plus 4 times 5. And then combining my like term, or simplifying in each of these, I get vector 7, 8. So therefore my solution, written as an ordered pair, is going to be 7, 8. So that is how we solve a system of equations using an inverse matrix. In the final set of videos we're going to have for this semester, we're going to talk about a different way that we can use matrix representation of a system of equations to solve it. That does end up simplifying things quite a bit.